how to analyze the two-dimensional elements using analytical equations as well as Mohr circle. So now in this present class, we will move on to a few of the MCQ questions, whatever remaining. But also next we try to move on to the next topic, failure theories. Once we know how the two-dimensional stress system will behave under normal stresses as well as combination of normal and shear stresses as well as pure shear stresses, the next thing is what are the possible kinds of theories of failures we may expect in those two-dimensional stress elements. So very, very important, because we know that there are the possibility of material may be failed due to stresses, say increased enormously in the because of external loading. There may be a failure due to stress. There may be a failure due to strain. So a few of the stalwarts like St-Venants, Rankines, Higgs. So there are several stalwarts have given a few failure theories. So after the whatever two-dimensional stress analysis, how to compute principal stresses, major principal and minor principal stresses, shear stresses, we will further try to move on to the next topic, that is failure theories. Okay, shall we start whatever the remaining few MCQ questions? Shall we start? Ready, Dirappa?
Yes, sir.
Okay, thank you. Is the screen is visible?
Yes, sir.
Okay. So I think this question is over. So any doubts in this question? The radius of Mohr circle of stress is trying to element, that is radius is given, and also minimal principal stress is given. The major principal stress sigma 1, how much? That is 30. We computed in last class. So we will move on to the next question. See the next question. If an element of a stressed body is in a state of pure shear with a magnitude of 80 Newton per mm square. So what he is telling in the problem, if you consider an element or body, it is subjected to pure shear stress. So what is meant by pure shear stress? What is meant by pure shear stress? There is no normal stresses. This is a pure shear stress, 80. The magnitude of maximum principal stress at the location is, he is asking to compute what is the magnitude of maximum principal stress, which means sigma 1. Maximum shear stress means sigma 1, that is major principal axis. What is sigma 1? Yes, please tell me what is sigma 1 value. Yes, you can try with the help of Mohr circle, or you can use analytical equation. If you try with Mohr circle, what happens? If you consider it as x-axis, as well as if you consider y-axis, there is zero shear stress, and this is, if it is clockwise, you can take negative, anti-clockwise you take positive. First I'll consider x direction. There is no normal stress, therefore 0 at 0 point. It is having anti-clockwise of 80, which means positive 80. So this is 80. Another one is negative 80. So this is the radius, this is the circle. So if you draw the Mohr circle, what happens? If you have to join with, this is the point. Now, what is the maximum principal stress? Here to here distance. What is this? This is sigma 1. So what is the value here to here? That is radius. What is the value?
80.
So let's see the answers. Yes. Any doubts? The answer is, what is the answer?
80.
A. 80. A. Clear? Any doubts?
No, sir.
Others? Any doubts? Other students? If you're having any doubts, this is very, very important topic. May expect very, very important question in this particular topic. See, next problem. At a point in elastic medium, normal stresses in two mutually perpendicular direction. See, what is two mutually perpendicular direction? This and this two mutually perpendicular direction, or 120. Always the first one is x-axis, so major 120, and another one is 40 MPa, 120 and 40 MPa, 120 and 40 MPa. Okay, so both tensile means what? Acting away from the body. If it is a material, both stresses are acting away from the body, so tensile, both are tensile. And also tau is given
30 MPa.
Tau is given as 30 MPa. Here also the same thing. This is 120 MPa, and also this is tensile 40 MPa, and also there are two set of same shears, that is 30. Yes. Now what he is asking? It's asking to compute the principal stresses. What are principal stresses? Sigma 1 and sigma 2. It's asking to compute the sigma 1 and sigma 2. See, all values are given. Please try to solve this problem. All values. Sigma x, this is sigma x, and this 40 is sigma y, and this 30 is tau xy. Now, what is the empirical relation? What is sigma 1 equation? You know that sigma 1 equation. What is sigma 1 equation? What is sigma 1 equation?
Rho x.
Tau x, sigma x plus sigma y. Yes. What is sigma 1 equation? Have to try. You try ಮಾಡಬೇಕು, ಇಲ್ಲ ಅಂದ್ರೆ ನಿಮಗೆ ಕಷ್ಟ ಆಗುತ್ತೆ.
Sigma x plus sigma y plus.
Yes. See, the equation is sigma 1 equals sigma x plus sigma y by 2 for
Plus.
maximum, plus square root of sigma x minus sigma y by 2 whole square plus tau xy square. What is the value of sigma x? What is the value of sigma x? 120. What is the value of sigma y? 40 na? 40 by 2 plus 120 minus 40 by 2 whole square tau xy. What is tau xy?
30 square.
30 square. Yes, determine the value. What is sigma 1? And if you want sigma 2 is whatever 160 by 2 is 80 minus whatever the value here you are getting.
130, sir.
130, yeah. Okay, 130 MPa tensile you are getting positive. Okay. For this,
30
how
MPa.
much? 80 by 2 is 40 square plus 30 square. ಎಷ್ಟು ಬರ್ತಾ ಇದೆಯಪ್ಪ?
30 MPa, sir.
Positive or negative?
Positive, sir.
Okay,
Positive, sir.
It is also tensile. Let's see the answers.
Both the tensions.
Yes. What is the answer? Option
B.
B. See, option B is right. Both sigma 1 is 130 MPa tensile and sigma 2 is 30 MPa tensile. Both are tensile. So any doubts? Students, any doubts?
No, sir.
Okay, good.
No, sir.
Yes. Next question. See, try to solve this problem. At a point on the surface of a generator shaft, the stresses sigma x 50 MPa, sigma y 10 MPa, and tau xy minus 40 MPa, shown in figure. See the figure. See, figure is given. Why the figure C, you see in large cases whatever we are representing the positive shear, on that case the shear I have represented on this side, say clockwise. But when you are giving negative on the top surface, you have to see the first top surface, so that is negative. So anti-clockwise direction, so minus 40. Okay, so sigma x, sigma y, tau xy. How to compute normal stresses? What is the equation?
Rho
Sir,
x
ಈ
plus
ಪ್ರಾಬ್ಲಮ್
rho y.
ನಿನ್ನೆ ಆಗಿದೆ ಸರ್.
ಆಗಿದೆಯಪ್ಪ? Okay, what is the answer?
-60.
Minus 60. Okay. Next. So the thing is, for the same problem, What is the major principal stress? You have to take these values. For the same problem. What is sigma 1? What is sigma 1? What is sigma 1?
ಸರ್ ಸೌಂಡ್ ಬರ್ತಾ ಇಲ್ಲ.
ಸೌಂಡ್ ಬರ್ತಾ ಇಲ್ವಪ್ಪ? ಕೇಳಿಸ್ತಾ ಇದೆಯಾ?
ಸರ್ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಆಗ್ತಾ ಇದೆ ಸರ್.
ಬೇರೆಯವರೆಲ್ಲ ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಚೆನ್ನಾಗಿರುತ್ತೆ.
Yes, others please unmute. ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? Is any problem?
Veeresh HV.
Am I audible? Clarity ಇದೆಯಪ್ಪ?
Yes sir.
Okay. What is
ನಿಮ್ದು
sigma 1
ವಾಯ್ಸ್ ಕೇಳಿಸ್ತಾ
equation?
ಇದೆ ಸರ್, ನಿಮ್ದು ಕೇಳಿಸ್ತಾ ಇದೆ, ಬೇರೆಯವ್ರ ಕಡೆಯಿಂದ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಇದೆ.
Yes. Okay. What is sigma 1 equation? You know equation. What is the equation? Sigma x plus sigma y by 2. That is 50 plus 10. 50 plus 10. 60 by 2. 60 by 2 is 30 plus square root of sigma x minus sigma y. 50 minus 10. 40 by 2 whole square. 40 by 2 whole square means 20 square plus tau xy square. So if you minus whole square, it will become positive only. Nothing to worry about. Positive, negative of tau xy. Yes. Compute sigma 1. What is sigma 1? That is major principal stress. So whatever this value, this is sigma n. How much you are getting? Sigma 1. Similarly, try to determine sigma 2 value. Sigma 2 is 30 minus whatever the square root of 20 square plus 40 square. You are getting sigma 2. That is major principal stress and minor principal stress. Yes, what is sigma 1? How much you are getting sigma 1?
74.
How much?
74%.
74 point?
Something 70.
What is sigma 1?
74.72.
70.17, na?
74.72.
Minus or plus?
Plus.
Plus.
Okay. What is minor? So here,
Minus 4.
what is minor? What is sigma 2? So sigma x plus sigma y by 2. How much you are getting? Sigma 2? This is major. It's asked, okay. Next, what is tau? Tau max value or tau? Tau equal sigma 1 minus sigma 2 by 2. What is tau value? Compute the shear stress also. Compute the shear stress also. What is the value of shear stress? Once you are getting sigma 1, sigma 2 value, easily you are getting the tau value.
30 sir.
30. Yes. Have you got the C? Please check the answers. First is, have you got minus 60 MPa for the sigma n? Yes, right. Next, sigma 1. Sigma 1, have you got plus 30 MPa? Please check.
Yes, sir.
Sigma 1, have you got plus 30 MPa?
Yes, sir.
Okay.
Yes sir.
Next, please check. Have you got the answer of shear stress? Shear stress, how much you got? 50? Have you got 50?
Yes, sir. Yes, sir.
Remaining students, others, please check. Have you got 50? See here, what you have to observe. Please don't substitute directly. Sumne eno madak hobedi direct agi. Why? Because you have to see the diagram. If you see the diagram, how sigma x is acting? Tensile or compressive?
Compression.
Compressive value is
Minus 50.
If you see sigma y, what is sigma y?
Plus 10.
So plus 10. So now if you see this, how much you are getting? Minus 50 plus 10. 40 by 2 is 20. Right?
Minus
Here you are
20,
getting-
sir.
Minus 20.
Yes. Okay. Please, if the figure is given, you have to see the figure. If you see the value is given positively, but he mentioned in figure compression and tensile nature. Clear? Don't make any mistakes. This is over. Yes. Have you got the answers? Bantapa, shall we move on to next problem? ಹೇಳ್ಬೇಕು ಓಕೆನಾ ಅರ್ಥ ಆಗಿದ್ಯಾ ಏನೋ ಡೌಟ್ಸ್ ಇದೆಯಾ if you having any doubts ask me I will clarify okay this is over this is also over yes take this problem see this problem what is given that a strain now you have to use the empirical equation associated with strain. What is given? A body is subjected to two normal strains. The body is subjected to two normal strains. If a body, this particular object or lamina, this lamina is subjected to two strains, that is epsilon x and epsilon y. The shearing strain is inclined at 30 degree. The shearing strain is inclined at 30 degree. So what is the strain? Total strain. You have to compute the total strain. So the equation for this, you have to remember, please take the note down in this equation. You have to remember that pi, whatever the angle theta, here 30 degree is given. The equation is given by epsilon x minus epsilon y divided by 2 into sine 2 theta. Sine 2 theta. Yes, this is the equation you have to remember. Very simple equation. Epsilon x minus epsilon y divided by 2 into sine 2 theta. Yes, substitute all the values. You know epsilon x. Epsilon x is 0.003. And what is epsilon y? 0.002 divided by 2 sine 2 theta. Theta is given as 30 degree. Theta is given as 30 degree. Yes. How much you are getting? What is angle? What is the thing? Strain 30 degree. How much? If you solve this, you are getting 0.003 minus 0.002, which means 0.001. 0.001 divided by 2 into what is sine 60? What is sine 60? Root 3 by 2. Sine 60 is root 3 by 2. Now you are getting 0.001 can be written as 10 power minus 3. 10 power minus 3. What is the remaining thing? Root 3 divided by 2 2s are 4 into 10 power minus 3. Which one is the answer?
Option B.
B. See, root 3 by 4 into 10 power minus 3. 2 2s are 4. So root 3 by 4. 0.001 can be in other terms in 10 power was written as 10 power minus 3. Any doubts? Any doubts?
Sir, ಈ ಫಾರ್ಮುಲಾ ಹೇಳೇ ಇಲ್ಲಲ್ರಿ ಸರ್?
Note presentation no? Have you seen the presentation? I will show you.
Okay.
ಇಲ್ಲ ಸರ್ ಹೇಳಿಲ್ಲ.
Presentation ಅಲ್ಲಿ ಇದೆ principal strain. ನಿಮಗೆ ಸೆಂಡ್ ಮಾಡಿದೀನಲ್ಲ presentation. Check the presentation. You are having that equations.
ಚೆಕ್ ಮಾಡ್ತೀನಿ ಸರ್.
See, for this generally the only possibility is see principal strains. I have given the equations. You observe here principal strains in inclined direction after Mohr circle. Okay, these are the things you have already given, but the thing is you have to use the equation for only what he is asking. He is asking the two normal strains, so that way there is no shear strain. So generally they will ask on only stresses, but in few cases you may expect the direct formulas. These are the formulas. See, whatever you have done with respect to Mohr circle stresses, that is principal stress sigma 1, sigma 2. Instead of sigma 1, sigma 2, here you are having epsilon 1, epsilon 2. See, Ex, E1, E2. Same equation. Instead of tau xy whole square, here you have to get sigma xy by 2 whole square. Sigma x by 2, that is pi xy by 2 whole square. Clear? Okay, only the thing, 99.9% you are getting in stresses. I am clearing you peoples. Okay, generally they won't ask principal strains. Definitely 100% they will ask principal stresses, but you must know, because there is a part in syllabi, so that's why you must know at least the basic thing. It's a shear strain equation. So any doubts?
No, sir.
Okay, clear? Okay, shall we move on to the next topic? Any doubts in this particular topic? If you're having any doubts, please inform me. I will clarify your doubts, or else I will move on to the next, a very, very important topic. The topic is failure theories.
Sir.
Yes, students, any doubts? Shall I move on to the next topic? Yes.
Yes.
Yaro ena kedidri. Any doubts? Ilva, shall I move on to next topic? Okay. This next topic is failure theories. Okay. Yes. What is mean by failure? You have to discuss. What is mean by failure? See, I have explained several things. I have explained the basic things, different types of materials, different types of stresses, and also I have explained uniaxial stresses as well as biaxial stresses. You are having only two kinds. Uniaxial means the force is applied in one direction, hence the stresses will produce in one direction. Biaxial means the force, we are applying both normal as well as shearing stresses. Hence, here also you may expect different kinds of stresses. And also you are not having triaxial. So here, what are different failures? I am asking a general question. What are different failures? ನೀವು BMT lab ನಾಗೆ ಟೆಸ್ಟ್ ಮಾಡಿದಿರಲ್ವಾ, ಯಾವ ಟೈಪಿಂಗ್ ಫೇಲ್ಯೂರ್ ಆಗ್ಬೋದಪ್ಪ?
Shear failure.
Yes, shear failure. Others? Any other answers?
Compression failure.
Buckling failure, sir.
Yes, buckling, short column. Okay. Yes, any others? Okay. Generally, what is the reason of failure? See, when we are talking about specifically a two-dimensional stress system, that is what happens in two-dimensional stress system. Generally, both normal stresses as well as shear stresses, both are comes into picture. Both normal as well as shearing action will come into picture. What happens? So there are basically two types of failure will come across these kinds of system. What are those? The material may fail due to yielding, or the material may fail due to fracture. So what is mean by yielding and what is mean by fracture? So yielding means, see an example for when you are testing a mild steel under universal testing machine. What happens? The stress strain will give these salient features, like it may be elastic point, and also it will give some plastic limit, elastoplastic limit. Afterwards it will start to aid, it will try to recover its original state. Afterwards it fails, and here you are getting yield point as well as ultimate. Here ultimate point you are getting, here yield you are getting, here your plastic limit you are getting different. And the deformation whatever in these kinds, yielding, this is larger one, it's a larger one, right? So those kind of materials is termed as ductile material. Generally yielding can occur in which kind of material? In ductile material. What are mean by ductile materials? Ductile materials are those materials which is having under the load, it will show excessive deformation characteristics, as well as it will produce different salient features like elastic limit, elastoplastic limit, plastic limit, yield point, and ultimate point. Finally, it will come to fracture point. But what happens in case of brittle materials? What happens in case of brittle materials? There is no specified features. See, if you see the concrete strength curve, what happens? There is no elastic or any specified region. It will just fail. Some certain point, it fails suddenly. Unrecoverable plastic hinges will form at few regions. It will fail suddenly. So those kinds we call it as fracture. And also we shown in first class, what are the possible failure pattern when the material is subjected to tension and when the material is subjected to compression. When brittle material is subjected to compression, we can see the bulging action. But when ductile material subjected to this particular thing, we can see bulging action. But brittle material subjected to compressive, what happens? It will get 45-degree failure pattern. Similarly, the tensile force, if you can apply tensile force, here we can see cup and cone arrangement and 45-degree failure line. So all those things we have already studied in first class. You have to remember the things. But here, what you must know, the material basically of two types, ductile material and brittle material. Ductile material, when it fails under yielding, brittle materials, it fails under fracture. Any doubts? Okay.
No, sir.
Yes, see, this is very, very important. You may expect theory question in this particular part, or else in this part. Generally, we are expressing the thing in terms of percentage elongation. If the percentage elongation is less than 5%, the material is brittle. If the percentage elongation is greater than 15%, the material is ductile. You may expect a question. If a material is having a percentage elongation of 25%, so the material can be classified under composite, brittle, ductile, none of this. Okay, you may expect a question. So in this case, you must remember the percentage of elongation is less than 5%, the material is classified as brittle. But the given thing is, it's given 25%, which means it is greater than 15%. Obviously, it is ductile. What is elongation indicates? Elongation, which indicates that the deformation, that is delta. That's a deformation, delta. That is, I have already stated that ductile materials are having yield. Yield means that is, it is having longer elongation. It's having longer elongation. But brittle, there's no elongation. It will fail suddenly. Hence, the percentage of elongation is less in case of brittle material. The percentage of elongation is huge, high in case of ductile materials. Any doubts? Clear?
Yes, sir.
Okay. See, next, the thing is very, very important thing. Different theories of failures. Okay. Anybody, if you know any theories of failures, please state few theories of failures. Please try to say few theories of failures. ಗೊತ್ತನಪ್ಪ ಯಾವ್ದಾರು ಜನರಲ್ ತಪ್ಪಾದ್ರೂ ಪರವಾಗಿಲ್ಲ ಟ್ರೈ ಮಾಡಿ.
Elastic theory.
Yes, next. Okay, just observe. Have you heard the thing maximum principal stress theory? It is also called Rankine's theory. Very good. So maximum principal stress theory. What is maximum principal stress? We already discussed in two-dimensional stress analysis. What is maximum principal stress?
Sigma 2 major principal stress.
Sigma 2 is minor.
Sorry, sigma 1 maximum.
Don't make confusion or new confusion agbedi, berorgo confusion madbedi. Clarity irli. Sigma 1 is major principal stress. Yes, okay. Sigma 2 is minor principal stress. Here, maximum principal stress. Which one is maximum principal stress? Major or minor? Sigma 1 or sigma 2?
Sigma 1.
Sigma 1.
Yes. So this particular theory is talking about sigma 1, which is what? Major principal stress. This theory is given by Rankine. Hence, this theory is also called Rankine's theory. So you know the equation sigma 1. So in this theory, if the material sigma 1, if exceeds the value of yield sigma y by 2, the failures occurs inside the material. This, what is sigma y? You know the stress strain graph. You know the stress strain graph. Here, this is one point, this is ultimate point, and this is yield point, and this is fracture point. This is yield at within elastic limit. So if it is exceeds sigma 1, then these principal stresses, the material will fails due to mainly of stresses. Hence, it is called maximum principal stress theory. Okay, we will discuss in detail, nothing to worry. But the name itself indicates this is major principal stress. What it indicates, the material fails because of stress induced, especially the major principal stress sigma 1. Okay, so what is sigma 1? You know that the equation you have to remember. What is the equation? Sigma 1, sigma x plus sigma y by 2 plus square root of sigma x minus sigma y by 2 whole square plus tau xy whole square should greater than sigma y by 2. This is the thing you have to remember. I will discuss in detail, nothing to worry. Yes, what is the second one? Maximum principal strain. Maximum principal strain theory. This is also called Saint Venant's theory. See, in MCQ question, they will set like match the following. Match the following. Maximum principal stress theory. They will mention some other, every theory proposed by some of the scholars. You have to remember those scholars' name, or sometimes they will ask directly the scholar name. Okay, this particular part will help to study the match the following. So specially they will fix a question in match the following. So, okay, what is maximum principal strain? What it indicates? The material fails in strain. Here the material fails in stress. If the material fails due to excessive strain, the theory is called maximum principal strain theory. The material fails due to maximum stress, the theory is called maximum principal stress theory. Maximum principal stress theory is also called Rankine's theory. Maximum principal strain theory is also called Saint Venant's theory. Clear? Yes. Next one is shear strength. See, what we studied in two-dimensional stress, we studied sigma, that is we studied sigma 1, sigma 2, we studied strain, epsilon, and also we studied tau. So these are the three things. This is maximum principal stress theory, maximum principal strain theory, maximum shear stress theory. What is maximum shear stress theory? This is also called Coulomb's, Tresca, and Guest. See, Coulomb's theory is different, Tresca and Guest theory is different, but all three talking about the material fails due to shear stress. The material fails due to shear stress. If excessive shear stress causes failure of material. In this case, excessive principal strain causes failure of material. In this case, excessive principal stress will cause failure of materials. Any doubts? Any doubts? Any doubts?
Oh, sir.
No, sir.
Okay,
Oh,
this is
sir.
maximum shear stress. Next one, maximum strain energy theory. This is very, very important one. So we are dealing with what is meant by strain energy, how we are getting equations and all. In coming classes subsequently, we are dealing with this particular thing. But you have to be remember in this failure theories only. Strain energy. What is meant by strain energy? Any idea? What is meant by strain energy? Any idea? Any answers? Strain energy and Reno. Have you heard the word strain energy? I think in essay 1 alva ನೀವು ಓದಿದ್ದು structures 1, analysis of determinate structures. Yes, what is meant by strain energy?
Energy which is stored in the body due to strain.
Yes, right. It's a energy stored inside the body. When it comes into picture, the next question, once you're telling that this is the inside stored energy, when the utilization of that particular energy comes into picture, yavaga? When the material will get the action. When the material will get the action, then the material possesses reaction. So what happens in reaction? The energy comes into picture. whatever the stored energy will start to utilize. ಈಗ ಏನಪ್ಪಾ, ಈಗ ನಿಮ್ಗೆ ಶಕ್ತಿ ಇರುತ್ತೆ, ನೀವು ಸುಮ್ಮನೆ ಇರ್ತೀರಾ, ಸುಮ್ಮನೆ ಕೂತಿರ್ತೀರಾ, ಐಡ್ಲ್ ಆಗಿರ್ತೀರಾ, ಯಾರೋ ಒಬ್ಬ ಬಂದು ನಿಮ್ಗೊಂದು ಹೊಡಿತಾನೆ, ನೀವೇನ್ ಮಾಡ್ತೀರಾ, ವಾಪಸ್ ತೆಗೆದು ಬಿಡ್ತೀರಾ. ಅಂದ್ರೆ ಏನು, ನಿಮ್ಮ ಹತ್ರ ಎನರ್ಜಿ ಇದೆ, ಸ್ಟೋರ್ ಆಗಿದೆ, ಯು ನೋ ದಟ್ ಇಸ್ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ. But when it is the utilization of strain energy comes into picture, whether you have to do some kind of work, then the energy you are utilizing. ಈಗ ಜಿಮ್ಗೆ ಹೋಗ್ತೀರಾ, ವರ್ಕೌಟ್ ಮಾಡ್ತೀರಾ, ಏನದು ಎನರ್ಜಿನ ಕನ್ಸ್ಯೂಮ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂತ ಹೇಳ್ತೀರಾ ಅಲ್ವಾ. ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ನೀವು, ಇನ್ಸೈಡ್ ಎವ್ರಿ ಬಾಡಿ ನಿಮ್ಗೆ ಹೇಗೋ ಹಾಗೆ ಮೆಟೀರಿಯಲ್ಸ್ ಅಲ್ಲೂ ಸಹ ಎನರ್ಜಿ ಸ್ಟೋರ್ ಆಗಿರುತ್ತೆ. ಆ ಎನರ್ಜಿ ಯಾವಾಗ ಯೂಸ್ ಬರುತ್ತೆ, ನಿಮ್ಗೇನೋ ಜೀವ ಇದೆ, ನೀವು ನಡಿತೀರಾ, ಕೂತ್ಕೋತೀರಾ, ಓಡಾಡ್ತೀರಾ, ಅವಾಗ ಯುಟಿಲೈಸ್ ಆಗುತ್ತೆ. ಮೆಟೀರಿಯಲ್ ಮೇಲೆ ಲೋಡ್ ಬಿದ್ದಾಗ ಯೂಸ್ ಆಗುತ್ತೆ. when the material will get the experience of load or force, the strain energy utilization comes into picture. Any doubts? Clear? Strain energy ಗೊತ್ತಾಯ್ತೇನ್ರೋ? am I audible?
Yes, sir.
ನೀವು ಮಾತಾಡ್ಬೇಕು, ನೀವು ಮಾತಾಡಿಲ್ಲ ಅಂದ್ರೆ ನನಗೆ ನೀವು ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಲ್ಲ, ಗೊತ್ತಾಗ್ತಾ ಇರಲ್ಲ. So any doubts in strain energy? This is the energy stored in the material. Okay, we will discuss in detail, no problem. The next one, what is next one? Distortion energy theory. See, this is very very important. Maximum strain energy is also called Beltrami theory or Haick's theory. Beltrami theory or Haick's theory. See, ಇದನ್ನ ತುಂಬಾ ನೆನ್ಪಿಟ್ಕೊಳ್ರಪ್ಪ. ಜನರಲಿ ಮ್ಯಾಚ್ ದ ಫಾಲೋಯಿಂಗ್ ಅಲ್ಲಿ ಪಕ್ಕಾ ಕ್ವಶನ್ ಇದು. ಮ್ಯಾಚ್ ದಿ ಫಾಲೋಯಿಂಗ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಯುಜಿ ಇದು ಆಕ್ಚುಲಿ ದಿಸ್ ಇಸ್ ದ ಟಾಪಿಕ್ ರಿಲೆವೆಂಟ್ ಟು ಎಂಟೆಕ್. ಓಕೆ, PG ಸ್ಟೂಡೆಂಟ್ಸ್, ನಿಮ್ಗೆ ಸುಮ್ಮನೆ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಮೆಟೀರಿಯಲ್ಸ್ ಅಲ್ಲಿ ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಇಟ್ಟಿರ್ತಾರೆ, ನೀವೇನು ಸರಿಯಾಗಿ ಓದಿರಲ್ಲ. ಬಟ್ ದಿಸ್ ಇಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಇನ್ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್. ದಿಸ್ ಇಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್ ಇನ್ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್. ಸೊ ಎಸ್ಪೆಷಲಿ ನಿಮ್ಗೆ ಸಿಂಪಲ್ ಆಗು ಇರುತ್ತೆ, ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಆಗು ಇರುತ್ತೆ. ನೀವು ಒಂದನ್ನ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ, ಎನರ್ಜಿಗೆ ಹೋಗಿ ಇವನ್ ಹೆಸರು ಹಾಕೋದು, ಇವನಿಗೆ ಅವನ ಹೆಸರು ಹಾಕಿದ್ರೆ ಮುಗ್ದೋಯ್ತು, ಅಲ್ಲಿಗೆ ತಪ್ಪಾಗ್ಬಿಡುತ್ತೆ. So these are the 5 theories of failures. Very very important. Okay, distortion energy theory is also called one messes and Henke theory. These two, whatever maximum strain and distortion related to energy, that is, this is the energy stored inside the body. When subjected to load, it will come into utilization in terms of stresses or strain. So this is called strain energy. And distortion energy theory means when the body experiences a huge load, what happens, the material behaves drastically, which means the energy will lost suddenly. Sudden destruction of the material failure occurs. Because of this, the material fails. So that particular theory is called distortion theory, and also that is called one messes and Henke theory. Okay, ನಿಮ್ ಮೇನ್ ಆಗಿ ನೀವೇನ್ ನೆನ್ಪಿಟ್ಕೋಬೇಕು ಅಂದ್ರೆ, ನಿಮ್ಗೆ ಯಾವ ಥಿಯರಿ ಯಾರು ಮಾಡ್ದ, ಈ ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೆಸ್ ರ್ಯಾಂಕೈನ್ಸೋ, ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೈನೋ ಸೆಂಟ್ ವೆನಾಂಟ್ಸೋ, ಶಿಯರು ಕುಲಂಬೋ ಟ್ರೆಸ್ಕಾ ಗೆಸ್ಟೋ. ಸಮ್ ಟೈಮ್ ಏನ್ ಮಾಡ್ಬಿಡ್ತಾನೆ, ಸೊ ನಿಮ್ಗೆ ಇದು 3 ಜೊತೆಗೆ ಇನ್ನೊಬ್ಬನ್ ಹಾಕ್ಬಿಡ್ತಾನೆ, ಗೆಸ್ಟ್ ಜೊತೆಗೆ ವೆನಾಂಟ್ಸ್ ಸೇರಿಸ್ಬಿಡ್ತಾನೆ. ಸೊ ಐಡೆಂಟಿಫೈ ವಿಚ್ ಈಸ್ ನಾಟ್ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಥಿಯರಿ. ಸೊ ಇಲ್ಲಿ ಸೆಂಟ್ ವೆನಾಂಟ್ಸ್ ಥಿಯರಿ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಥಿಯರಿ ಅಲ್ಲ, ಅದ್ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. ನೀವು ಇವ್ 3ರಲ್ಲಿ ಯಾವ್ದಕ್ಕೂ ಟಿಕ್ ಹಾಕ್ಬಿಡ್ಬಾರ್ದು. ಇನ್ ಸಮ್ ಕೇಸಸ್ ಮ್ಯಾಚ್ ದಿ ಫಾಲೋಯಿಂಗ್ ಅಲ್ಲಿ ಯಾರು ಒಬ್ಬನ್ ಕೊಡ್ತಾನೆ, ಇನ್ನೊಬ್ಬನ ಸುಮ್ನೆ ಎಕ್ಸ್ಟ್ರಾ 5ನೇವನ್ನ ಕೊಟ್ಟಿರ್ತಾನೆ, ನೋಡೋಣ ನೀವೇನಾರು ಮಾಡ್ತೀರಾ ಅದನ್ನ ಅಂತ. ಗೊತ್ತಾಯ್ತಾ? ನೀವು ಇಷ್ಟು ಜನನು ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೆಸ್ ರ್ಯಾಂಕೈನ್, ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೈನ್ ವೆನಾಂಟ್ಸ್, ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಕೂಲಮ್ ಟ್ರೆಸ್ಕಾ ಗೆಸ್ಟ್, ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಬೆಲ್ಟ್ರಾಮಿ ಆರ್ ಹೈಗ್, ಡಿಸ್ಟಾರ್ಷನ್ ಎನರ್ಜಿ ವೆನ್ ಮೆಸಿಸ್ ಹೆನ್ಕಿ. ಸಮ್ಟೈಮ್ಸ್ ಇವೆರಡು ಸೇರಿ ಬರೀ ಎನರ್ಜಿ ಥಿಯರಿ ಅಂತ ಕೊಟ್ಬಿಟ್ಟು ಯಾರನ್ನಾರು ಒಬ್ಬನ ಹೆಸರು ಕೊಟ್ಟಿರ್ತಾನೆ, 4 ಕೊಟ್ರೆ. ಸೊ ಮ್ಯಾಚ್ ದಿ ಫಾಲೋಯಿಂಗ್ ಗೆ ದಿಸ್ ಇಸ್ ಅ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್. ಸೊ ಎನಿ ಡೌಟ್ಸ್?
No, sir.
Okay, let me move on to the thing in detail. Okay, now maximum principal stress theory or Rankine's theory. What is this? See, I already told that according to this theory, the failure of a material or component will occur when maximum value of principal stress developed in the body exceeding the limiting values. So I already told you that the thing is, what is the condition? See, that is sigma 1 is greater than sigma y. So what is sigma y? This is the yield. Yield strength. This is the yield strength. This is the yield. Okay. Now, what is sigma max? This equation, you know that. What is the equation? This is one. This one is, what is this? Major principal stress. What is the major principal stress? Sigma x plus sigma y by 2 plus square root of sigma x minus sigma y by 2 whole square tau xy square. So this is very, very important one. So this theory is majorly applicable for which kind of material? That is very, very important. Generally, they will ask. So maximum principal stress theory is quite suitable for which type of material? Brittle material. As brittle materials are weak with respect to tension, hence it is much suitable for brittle materials. So maximum principal theory, what are the important points you have to keep in your mind? One is the condition. What is the condition? So which major principal x, that is the major principal stress, it exceeds sigma y, that is yield stress. This kind of failure comes into picture. That is the first point you have to remember. What is the second point you have to remember? This theory is applicable for which kind of material?
Brittle.
Brittle. This kind of theory
Material.
we can see in brittle materials. So these 2 points you have to remember. Okay. Shall we move on to next theory? Any doubts in this theory?
No, sir.
Okay, this is maximum principal stress theory. Next, we move on to maximum principal strain theory, or we call it as Saint Venant's theory. See, the statement is very simple. As usual, the failure of material will occur due to maximum value of principal strain. But in previous case, that is due to principal stress. In this case, this is due to principal strain. That's all. Remaining thing, nothing to worry about remaining thing. Okay, condition. See the condition, epsilon 1 or epsilon greater than sigma y by E or sigma yield point. Okay, sometimes, see, this is the condition you have to remember. They will ask in match the following, they will give equation. See, the possibility of match the following is huge in this particular content. One with respect to a researcher's name, one with respect to equations. That is maximum principal stress theory equation. You know that sigma 1 it should be greater than sigma y. For this, epsilon 1 greater than sigma y, or this is the equation, very, very important equation. Please try to keep in your mind at least sigma 1 minus mu times of sigma 2 plus sigma 3 less than or equal to sigma y. So, or sigma 1 minus mu times of sigma 2 for 2-dimensional case. You are having only 2-dimensional case. This is very, very important one. Whatever I have highlighted in box, this is the thing. If I talking about maximum principal strain theory, see what the thing you have to remember. You have to remember 2 things. One is this one equation, sigma 1 minus mu times of sigma 2 less than or equal to sigma y. This is the condition. You have to remember this condition. In match the following, they will ask the condition, they will give on one side. Other side, they will give the Venant's theory, Rankine's theory, like that, whatever they can give. So on that situation, you have to match perfectly. And also, one more thing. So previous theory, which is applicable for brittle material, but this theory can be applicable for ductile material. This theory can be applicable for ductile one. And also here, I have mentioned the one thing. The yield locus of the point is parallelogram. This is very, very important. This can be also very, very important thing. You have to be kept in your mind. Maximum principal strain theory. There are 3 important factors you have to remember. One is yield locus. Yield locus is parallelogram. Please, someone ask me, sir, what is the yield locus for principal stress theory? I'm expecting from you people, you have to ask. Yes, okay, I will ask. Yes, What is the yield locus? Expected yield locus for principal stress theory? Guess. Circle, ellipse, rectangle. Any guesses? Please try to guess. Okay, no problem. That is here, that is rectangle. Yield locus is rectangle. Please keep these 3 points. One is condition, another one is brittle material, another one is yield locus, rectangle. For next one, keep these 3 points. What are these 3 points? It is the condition. Condition, sigma 1 minus mu times of sigma 2. Sigma 1 minus mu times of sigma 2 less than or equal to sigma y, and yield locus is parallelogram, and it is applicable for ductile materials. So any doubts?
No, sir.
Okay. See, next, maximum shear stress theory. This theory is also called Coulomb, Tresca, and Guest theory. This theory is also called Coulomb, Tresca, and Guest theory. See, this is very simple. Previously, what we stated that the failure of the material due to stress, that is maximum principal stress. Due to strain, that is maximum principal strain. Here, what is the thing? Shear stress. That's all. This is due to maximum value of shear stress. And that's why the material will fail. Hence, it is called maximum shear stress theory. What are the conditions? The condition is this. This is the thing you have to remember. This is the thing you have to remember. Here, major principal stress, minor principal stress. Whatever your value you are getting, that should be less than the value sigma y. So sigma 1 minus sigma 2 less than or equal to sigma y. Clear? So what is the yield locus? Here the yield locus is hexagon. In shear stress, what is the yield locus? Yield locus is hexagon. Yield locus is hexagon. See, these are very, very simple theories, simple equations, not complicated equations. So first thing, sigma 1 greater than or equal to sigma y. Second thing, sigma 1 minus mu times of sigma 2 less than or equal to sigma y. The third one is sigma 1 minus sigma 2 less than or equal to sigma y. See, ನೀವೆಂತ ಮಾಡಬೇಕು, ನೀವು ಸ್ಟಡಿ ಮಾಡಬೇಕಾದ್ರೆ ಎಲ್ಲ ಒಂದ್ ಕಡೆ ನೀಟಾಗಿ ಒಂದೇ ಪೇಜ್ ಅಲ್ಲಿ ಬರ್ಕೋಬೇಕು. ಯಾವ ಥಿಯರಿಲಿ ಏನೇನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ನಾನು ಹೇಳಿದೆ, ಮೂರೇ ಪಾಯಿಂಟ್, ಅದನ್ನ ಬರ್ಕೊಂಡ್ರೆ ನಿಮ್ ಮೈಂಡ್ ಆಗಿರುತ್ತೆ. ನಿಮ್ ಮ್ಯಾಚ್ ದಿ ಫಾಲೋಯಿಂಗ್ ಕೇಳಿ, ಇಲ್ಲ ಮಾಮೂಲಿ MCQ ಕೇಳಿ, ಈಸಿಯಾಗಿ ಮಾಡ್ತೀರಾ. See, this is very, very important topic. It's mentioned in your syllabi. Hence, you may expect 1 or 2 questions from this part also, because they will set the questions from this part, because here you are getting lot of confusions. So please be sure, don't make any confusion. Be a sure thing. The thing is, you have to take a note. What are the theories? Who are the researchers? And what are this equation or condition of failure? And what are the yield locus? These 4 things. You just take a note like this. One note ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ರಿ. Name of the theory. Name of the theory. Next, ಇನ್ನೇನ್ ಬರ್ತಪ್ಪ ಇದರಲ್ಲಿ, ನೇಮ್ ಅಲ್ಲಿ ರಿಸರ್ಚರ್ ನೇಮ್. ನೆಕ್ಸ್ಟ್ ಇನ್ನೇನ್ ಬರುತ್ತೆ? ಕಂಡೀಷನ್. ನೆಕ್ಸ್ಟ್ ಇನ್ನೇನ್ ಬರ್ಬೋದು? yield locus. ಆಮೇಲೆ ಇನ್ನೇನ್ ಬರ್ಬೋದು? ಸಾಕು, ಈ 4 ಇದ್ರೆ ಸಾಕು. ಇಲ್ಲ ಫೇಲ್ಯೂರ್ ಜೊತೆಗೆ ಫೇಲ್ಯೂರ್ ಯಾವ್ದಕ್ಕೆ ಅಂತ. ಫಸ್ಟ್ ಪ್ರಿನ್ಸಿಪಾಲ್ ಸ್ಟ್ರೆಸ್ ಆರ್ ಇದು ರಿಸರ್ಚರ್ಸ್ ರ್ಯಾಂಕೈನ್. ಕಂಡೀಷನ್ sigma 1 greater than or equal to sigma y. Yield locus rectangle. It's applicable for brittle material. ಅರ್ಥ ಆಯ್ತೇನ್ರಿ? ನೆಕ್ಸ್ಟ್ ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೈನ್. This is called Venant's. Here you are getting sigma 1 minus mu time of sigma 2, which is less than or equal to sigma y. Here yield locus is parallelogram. Here it is applicable for ductile material. So ಈ ತರ ನೀವು ಎಲ್ಲಾರನ್ನು ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ನೆನಪಲ್ಲಿ ಇಟ್ಕೊಂಡ್ರೆ ಸಾಕು. ಯಾವ ಮ್ಯಾಚ್ ದಿ ಫಾಲೋಯಿಂಗ್ ಬಂದ್ರು ಆರಾಮಾಗಿ ಮಾಡ್ಬೋದು. So clear? Any doubts? Any doubts?
No, sir.
No, sir.
Very good. Next we move on to the next thing, maximum strain energy theory or Beltrami theory or Hague theory. See here, you just observe here the failure of a material or component will occur when maximum value of strain energy. That's the thing. See the name lane bartado adrindane fail agate per unit volume exceeds. So strain energy ಜಾಸ್ತಿ ಆಗೋಯ್ತು, obviously failure ಆಗುತ್ತೆ ಮೆಟೀರಿಯಲ್ ಅಷ್ಟೇ, ಬೇರೆ ಇನ್ನೇನು ತಲೆ ಕೆಡಿಸ್ಕೊಳಕ್ ಹೋಗಬೇಡಿ. ಬಟ್ ಇದೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ಮೆಟೀರಿಯಲ್. ಸಿ ಯಾವ್ಯಾವ ಫೇಲ್ಯೂರ್ ಥಿಯರೀಸ್ ಹೇಳ್ತೀವಲ್ಲ ಎಲ್ಲ ಬೇಸಿಕಲಿ ವಿ ಡನ್ ಆನ್ ಎ ಟೆಸ್ಟಿಂಗ್ ಅಂಡರ್ ವಿಚ್ ಟೆಸ್ಟ್? ಟೆನ್ಷನ್. ಯು ಗೋ ಟು ಎನಿ ಥಿಯರೀಸ್ ವಾಟ್ ಎವರ್ ವಿ ಡಿಸ್ಕಸ್ಡ್ ಆಲ್ ಥಿಯರೀಸ್ ಆಫ್ ಫೇಲ್ಯೂರ್ಸ್ ರಿಗಾರ್ಡಿಂಗ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟೆನ್ಷನ್ ಕೇಳಬಹುದು MCQ ನಲ್ಲಿ. ಫೇಲ್ಯೂರ್ ಥಿಯರೀಸ್ ಆರ್ ಮೇಜರ್ಲಿ ಡ್ಯೂ ಟು ಶಿಯರ್, compression, tension, flexure. So on that case, which is the answer? What is the answer? Tension. Clear? Tension test ಅಲ್ಲಿ ಮಾಡಿದಾಗ್ಲೇನೆ ನಮಗೆ ಮೇನ್ ಆಗಿ ಫೇಲ್ಯೂರ್ಸ್. ಯಾಕೆಂದ್ರೆ we know that most of the materials are very strong in compression, but they are very very weak in tension. Clear? Now what is the condition? See, condition is very very important. See, this is the thing. This is very easy to remember. ಸೊ ನೋಡೋಣ, ಯಾರು ಗೆಸ್ ಮಾಡಿ ಈ ಈಕ್ವೇಶನ್ ಯಾವ ಈಕ್ವೇಶನ್ ತರ ಇದೆ? ನಿಮ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಒಂದು ಈಕ್ವೇಶನ್ ಇದ್ದಂಗಿದೆ. ಯಾವ್ದಿದು?
A square plus B square.
Yes, A square plus B square minus 2AB. What is the equation? That one. That is A minus B whole square equation ತರ ಅಲ್ವಾ? ಮ್ಯೂ ಒಂದನ್ನ ಇಟ್ಕೋಬೇಕಲ್ಲಿ ಅಷ್ಟೇ. ಅಂದ್ರೆ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಅಂದ ತಕ್ಷಣ ನಿಮ್ ತಲೆಗೆ ಬಂದ್ಬಿಡುತ್ತೆ A minus B whole square ಅಪ್ಪ, ಅದು A square plus B square ಅಂದ್ರೆ sigma 1 square plus sigma 2 square minus 2 mu into sigma 1 sigma 2. ಹಾಕಂಡ್ರೆ ಮುಗ್ದೋಯ್ತು. So any doubts in strain energy theory? Next, yield locus. See, ಇದನ್ನೇ ಈ ಈಕ್ವೇಶನ್ ಏನ್ ಮಾಡಿದಾನೆ? ಡಿವೈಡೆಡ್ ಬೈ ಸಿಗ್ಮಾ y ಮಾಡ್ಬಿಟ್ಟ. ಅವಾಗ ಏನಾಯ್ತು? sigma 1 by sigma y whole square plus sigma 2 by sigma y whole square minus 2 mu times of sigma 1 sigma 2 by sigma y square. ಇದು sigma y or sigma t both are same. So ಇದನ್ನ ಡಿನಾಮಿನೇಟರ್ ತಗೊಂಡ್ಬಿಟ್ರೆ ಈ ಈಕ್ವೇಶನ್ ಬರುತ್ತೆ. ನಿಮಗೆ ಮ್ಯಾಚ್ ದಿ ಫಾಲೋಯಿಂಗ್ ನಾಗ ಈ ಕ್ವಶನ್ ನಾರು ಕೊಡ್ಬೋದು ಆರ್ ಇದನ್ನಾರು ಹಾಕ್ಬೋದು. ಎರಡನ್ನೂ ಒಂದೇ. ಕ್ಲಿಯರ್? ಎನಿ ಡೌಟ್ಸ್? ಅಂಡ್ yield locus is ellipse. This is very very important. See, what is the yield locus for principal stress? Rectangle. Principal strain? Parallelogram. Strain energy? Yes, hexagon. And here maximum strain? Ellipse. See, these are the very very important thing. Only 3 to 4 key points. ಎಲ್ಲವನ್ನು ಓದ್ಲಿಕ್ಕೆ ಹೋಗ್ಬೇಡ್ರಿ, ಬರೀ ಮೇನ್ ಕೀ ಪಾಯಿಂಟ್ಸ್ MCQ ಕ್ವಶನ್, ದಟ್ ಈಸ್ ಎನಫ್. ಕೀ ಪಾಯಿಂಟ್ಸ್ ಓದ್ಬೇಕು, MCQ ನ ಮ್ಯಾಕ್ಸಿಮಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. MCQ ಕೀ ಪಾಯಿಂಟ್ಸ್ ಗೊತ್ತಿದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತಾಯ್ತಲ್ಲ. ನಿಮ್ಗೆ ಪ್ರಿನ್ಸಿಪಾಲ್ ಸ್ಟ್ರೆಸ್ ಪ್ರಿನ್ಸಿಪಾಲ್ ಸ್ಟ್ರೈನ್ ಅಂದ್ರೆ UG ನಲ್ಲಿ ಏನೋ ಅನ್ಕೊಂಡ್ಬಿಟ್ಟಿರ್ತೀರಾ. ನಿಮ್ಗೆ ಸಿಂಪಲ್ ಥಿಂಗ್, ಯಾವ್ದು ಈಕ್ವೇಶನ್ 3 ಈಕ್ವೇಶನ್ ನೆನ್ಪಿಟ್ಕೊಂಡ್ರಿ, ಮೋರ್ ಸರ್ಕಲ್ ನೆನ್ಪಿಟ್ಕೊಂಡ್ರಿ, ಯಾವ MCQ ಕೊಟ್ರು ಮಾಡ್ತೀರಾ ಅಲ್ವಾ? Now I think you are having confident to solve principal stress principal strain. ಇದೆಯಾ? ಕಾನ್ಫಿಡೆಂಟ್ ಇದೆಯಾ ಮಾಡೋದಕ್ಕೆ ಅಲ್ವಾ? Yes, right. ಅಷ್ಟೇ, ಎಲ್ಲಾ ಕಂಟೆಂಟ್ ಅಷ್ಟೇ, ಇದು ಬೇರೆ ಏನಿಲ್ಲ. ಕರೆಕ್ಟ್ ಆಗಿ ಒಂದು ವಾರ ಕರೆಕ್ಟ್ ಆಗಿ ಓದಿದ್ರೆ 2 ಅವರ್ 1 ಅವರ್ ಪಕ್ಕ ನೀವು ಯಾವ ಕ್ವಶನ್ ಕೇಳಿದ್ರು ಅಟ್ ಲೀಸ್ಟ್ ಯು ಆರ್ ಇನ್ ದ ಸ್ಟೇಜ್, you will guess the proper answer. That's all. Okay, here what are the 3 major aspects you have to remember? One is condition. What is the condition? That's in the form of A minus B whole square, that is minus 2 sigma 1 sigma 2 into mu. ಅಷ್ಟೇ, mu ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಹಾಕಬೇಕು. It should be greater than sigma y square. And another one is yield locus. Yield locus is ellipse. And this is also suitable for ductile materials. Next, the last one, I think, distortion energy theory, or also called Win-Massey's and Henke's theory. What it shows? See, distortion alli onde. We know that any material, if you consider any material, this is full of energy. How the energy will get distorted? By applying the various forces, this energy will start to dissipate. So What is the thing? This will be a summation of volumetric strain energy plus shear strain energy. So you may expect, what is total strain energy? That's the sum of volumetric strain energy plus shear strain energy. Right. What is the condition? See, this is a very simple condition. What is the condition? A square, that is sigma 1 square plus sigma 2 square plus minus sigma 1 sigma 2, which is equal to, see, be careful. In some cases, that is less than. In some cases, greater than. In some cases, equal. So ಅದಕ್ಕೆ equation condition ಬರ್ಕೋಬೇಕು ನೀವು. ಯಾವ್ದಾದ್ರು ಒಂದು ಕನ್ಫ್ಯೂಷನ್ ಆದ್ರೂ ಕ್ವಶನ್ ಇದಾಗ್ಬಿಡುತ್ತೆ. ಗೊತ್ತಾಯ್ತಾ? So this is distortion energy theory. Distortion energy theory, very very important. And one more point, what is the yield locus? Here also the yield locus is ellipse. Yield locus is ellipse. Now see, this is very very important diagram. They may ask like, ಈ figure ಕೊಟ್ಬಿಟ್ಟು ABCD ಹಾಕ್ಬಿಟ್ಟು match the following, ಯಾವ್ದು A ಯಾವ್ದು B ಕೋಡ್ ಕೊಟ್ಬಿಡ್ಬೋದು. Now observe, here you are having rectangle. See, this is major principal axis, minor principal axis, right? They have drawn a figure. This rectangle, what is the rectangle? What is the rectangle? Rectangle is maximum principal stress theory. Now this one, this locus, here you come like hexagon, parallelogram. Here you observe, this is the parallelogram. ಕಾಣಿಸ್ತಾ ಇದೆಯಾ? Have you observing?
Yes,
What is
sir.
parallelogram? What is parallelogram?
Maximum principal strain.
Yes.
Maximum
This is-
strain and principal strain.
Yes, parallelogram. Next, ellipse. Here ellipse. Ellipse ಕಾಣಿಸ್ತಾ? What is ellipse?
Ellipse maximum strain energy and distortion.
So anyone, ಅವನು ಯಾವ್ದು ಕೊಡ್ತಾನೆ ಅದು. Next, ಇಲ್ಲಿ ಒಂದು hexagon ಕಾಣಿಸ್ತಾ ಇದೆಯಾ?
Yes, sir.
This is hexagon. See, ಹಂಗ್ ಬೇಕಾದ್ರೂ ಮಾಡ್ಬೋದು. See, this is maximum shear stress theory. So any doubts? ಇಷ್ಟೇ ಇರೋದು ನಿಮ್ಗೆ failure theories ಅಂದ್ರೆ. Failure theories ಅಂದ್ರೆ ಇಷ್ಟೇ. Any doubts in failure theories?
No, sir.
Clear? The concepts are clear. See next.
Yes, sir.
See, this is very very important thing. Which theory best suit for brittle and ductile material? See, for brittle material, principal stress giving reasonably good results. Distortion energy theory is the most suitable. See, ನಿಮ್ಗೆ ಏನಾದ್ರೂ ನಿಮ್ಗೆ ಹೇಳಿದೆ, ನಾನು ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೈನ್ ಹೇಳಿದೆ, ಡಿಸ್ಟಾರ್ಷನ್ ಎಲ್ಲ ಹೇಳಿದೆ. ಎಲ್ಲಾ ಆಪ್ಷನ್ ನಾಗು ಬೆಸ್ಟ್ ಆಪ್ಷನ್ ಫಾರ್ ಡಕ್ಟೈಲ್ ಮೆಟೀರಿಯಲ್ ಅಂದ್ರೆ ವಿಚ್ ಒನ್? ದಟ್ ಈಸ್ distortion energy. And also in some cases ಈ ಡಿಸ್ಟಾರ್ಷನ್ ಕೊಡ್ಲೇ ಇಲ್ಲ, ಅವಾಗ ಮ್ಯಾಕ್ಸಿಮಮ್ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಕೊಟ್ಟಿದ್ದ, ಅವಾಗ ಯಾವ್ದನ್ನ ಟಿಕ್ ಹಾಕ್ಬೇಕು? ಮ್ಯಾಕ್ಸಿಮಮ್ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್, because we would use because of its simplicity. So any doubts? Next MCQ question. So tomorrow we will take MCQ question because it's already 6:58. Another 1 minute we are having. So if you are having any doubts, I will clarify your doubts. Please tell me if you have any doubts or you understand it very well. Understand ಆಯ್ತಾ ಇಲ್ಲ? ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ? Theories of failure ಕಷ್ಟ ಇದೆಯಾ?
No, sir.
How you are feeling? Are you facing any difficulties?
No, sir. No, sir.
No,
Are you following whatever I am telling? ನಾನು ಏನ್ ಹೇಳ್ತಿದ್ದೀನಿ ಫಾಲೋ ಮಾಡ್ತಾ ಇದ್ದೀರಾ? ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ?
Yes, sir.
ಕಾಸ್ಟ್ ಏನಾರು ಆಗ್ತಾ ಇದೆಯಪ್ಪ?
No, sir.
ಸರಿ ಇದೆಯಾ?
Yes, sir.
Okay, sir.
Okay, because we already finished 2 topics. This is 3rd topic. Okay, ಇನ್ನೂ ತುಂಬಾ ಇದೆ. ಈಗ ಥಿಯರೀಸ್ ಆಫ್ ಫೇಲ್ಯೂರ್ಸ್ MCQ ಮಾಡ್ಬಿಟ್ಟು ನಾಳೆ ಕ್ಲಾಸ್ ಮಿಸ್ ಮಾಡ್ಕೋಬೇಡಿ, 2 hours ಇದೆ. ನಾಳೆ ಥಿಯರೀಸ್ ಆಫ್ ಫೇಲ್ಯೂರ್ MCQ ಡಿಸ್ಕಸ್ ಮಾಡಿ SFD BMD ಹೇಳ್ಕೊಡ್ತೀನಿ. ತುಂಬಾ ಈಸಿ, ಕ್ವೈಟ್ ಇಂಟ್ರೆಸ್ಟಿಂಗ್. ನಿಮ್ಗೆ ಅದು ಬಂದ್ರೆ ಮಾತ್ರ ನೀವು ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಲೈನ್ ಡಯಾಗ್ರಾಮ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗೋದು. ಯಾಕೆಂದ್ರೆ ನಿಮ್ ಸಿಲೆಬಸ್ ನಾಗೆ ಬರೀ ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಲೈನ್ ಡಯಾಗ್ರಾಮ್ ತುಂಬಿ ಕೂತಿದ್ದಾನೆ. ಗೊತ್ತಾಯ್ತಾ?
Yes, sir.
ಮಿಸ್ ಮಾಡ್ಕೋಬೇಡಿ ನಾಳೆ ಕ್ಲಾಸ್ ನ. 11 o'clock ಇದೆ ಅಲ್ಲ ನಾಳೆ ಕ್ಲಾಸು?
Okay, sir.
ಓಕೆ, ಮಿಸ್ ಮಾಡ್ಕೋಬೇಡಿಪ್ಪ. ಥ್ಯಾಂಕ್ ಯು
Okay, sir.
ಥ್ಯಾಂಕ್ ಯು ಆಲ್.
Thank you, sir.
thank you.
Thank you, sir.